Hello everyone, my name is Sujan Dhar and I am a PhD student performing my research under the guidance of Professor Andrea Vacca. The topic of my research is fluid structure thermal interaction modeling of the lubricating interface in external gear machines. So this is how a typical external gear machine looks like, and the main internal components of the machine can now be seen. The lateral lubricating interface exists between the lateral bushes and the gears as shown. These lateral bushes are floating elements which are designed to be hydrostatically balanced. This is a delicate problem since the bushes must be designed for low leakage losses, meaning low gap heights, as well as low shear losses and wear, which means high gap heights. In order to achieve this without an expensive trial and error process, it is essential to have a predictive numerical model of the lubricating gap accounting for elastohydrodynamic and thermal effects. Thus, the fluid structure interaction model of the lateral gaps has a gap flow model which interacts with a kinematic solver for the force balance on the lateral bushing. In addition, the fluid structure interaction is modeled by coupling the flow model to a structural model. In order to model the thermal effects, there is a gap thermal model as well as a solid thermoelastic model, and all these models are fully coupled and can predict the film thickness, pressure and temperature and other parameters in the lubricating gap. So looking at the results, these are the gears rotating in a typical gear machine. Now we see the lubricating gap height prediction by the model, greatly exaggerated so that it is visible since this is of the order of microns. Now we see the film thickness and the pressure, and finally we also see film thickness, pressure and also the bushing micromotion as predicted by my model. The model is also capable of temperature predictions such as in the lateral gap of the gears and of the lateral bushing. All the predictions by the fluid structure interaction model are validated by performing experimental activity on the multi-purpose test rig in our lab, which you can see over here next to me. Over here there is a specially instrumented prototype pump with capacitive sensors embedded in it, which basically measures the lubricating film thickness as predicted by the model and can be used to validate the model. And we believe that our research will eventually drive the design of more efficient and reliable external gear machines. Thanks a lot for watching the video.